Hello everyone, welcome back to my channel. Today we are continue with the chapter Vector Algebra. In this video we will start with the next article. Article is Lagrange's identity. In this article we have to prove that if A vector and B vector are any two vectors, then A vector cross B vector whole square will be equals to the magnitude of A vector square into magnitude of B vector square minus of A vector dot product with B vector whole square. Now let us prove this identity. For proving, we have to take the left hand side, which will be equals to A vector cross B vector whole square. And we know that the cross product of two vectors will be equals to AB sine theta into n cap whole square, where theta is the angle between A vector and B vector and n cap is a unit vector. Then this will become A square B square sine square theta n cap square. That means this will become A square B square sine square theta into 1. That means this will be equals to A square B square sine square theta, and we know that sine square theta will be equals to 1 minus cos square theta. By putting the value of sine square theta, we get A square B square into 1 minus of cos square theta. That means this will become A square B square minus of A square B square cos square theta. That means it will also be written as A square B square minus of AB cos theta whole square. That means A vector cross of B vector whole square will be equals to A square B square minus of, this will be equals to A vector dot product with the B vector, or this will be also written as A vector cross product with B vector whole square will be equals to the magnitude of A vector square into magnitude of B vector square minus of A vector dot of B vector whole square. So hence this is the proof of the Lagrange's identity. Now first corollary is A vector cross B vector whole square plus A vector dot product with B vector whole square will be equals to A vector magnitude whole square into B vector magnitude whole square. Now corollary second is, since A vector cross of B vector whole square will be equals to magnitude of A vector square into magnitude of B vector square minus of A vector dot product with B vector whole square, this will be also written as mod of A vector cross of B vector will be equals to the square root of A vector square into B vector square minus of A vector dot with B vector whole square. So these are the two corollaries related to this identity. Now we have to start with the next article. Article is, let the vectors A vector, B vector and C vector be given as A1 I cap plus A2 J cap plus A3 K cap, B1 I cap plus B2 J cap plus B3 K cap, and C vector is C1 I cap plus C2 J cap plus C3 K cap. Then show that A vector cross of B vector plus C vector will be equals to A vector cross of B vector plus A vector cross of C vector. Now let us prove this article. In this article, A vector, B vector and C vector is given, which will be equals to A vector will be equals to A1 I cap plus A2 j cap plus A3 k cap. B vector will be equals to B1 I cap, B2 j cap plus B3 k cap, and C vector will be equals to C1 I cap, C2 j cap plus C3 k cap. Then we have to find B vector plus C vector. This will become B1 plus C1 I cap plus B2 plus C2 j cap plus B3 plus C3 k cap. Now we have to take the left hand side, which will be equals to A vector cross of B vector plus C vector. Now we have to find this cross product. A vector, B vector plus C vector will be equals to this, and A vector is this. So we will find the cross product between them. So now let us find the cross product. We have to take these three caps, I cap, j cap and k cap, and there will be, we take the value of A vector, that means A1, A2, A3. Then here we will take the values of B vector plus C vector, which will be equal to B1 plus C1, B2 plus C2, B2 plus B3. There will be B2 plus C2. Then there will be B3 plus C3. So now we have to solve this. By solving these, we get this will also written as I cap, j cap, k cap, A1, B1, A1, A2, A3, and there will be B1, B2, B3 plus I cap, j cap, k cap, A1, A2, A3, C1, C2, C3. That means this will be equals to, this will be equals to A vector cross of B vector plus this will be equals to A vector cross of C vector, which will be equals to the right hand side. So hence this is the proof of this article. Now in the next video we will start with the questions related to this exercise. So if you like my video, then please like, subscribe and share my videos, and do not forget to press the bell icon for the notification of the more videos. Thanks for watching.